Hey guys, how's it going? So we're continuing with our paper. Okay, so now we're on travel graphs. Okay, so this one is an interesting question, very rare as well. So I advise you to actually listen like very carefully, so that you'll be able to do well should this question be tested in your exam. Okay, so you have this one. It's a speed time graph, very popular. If you're doing physics, then you probably have a better understanding of travel graphs than people who are just doing combined science. But then still, I want you to listen like really carefully. Okay, if you're doing combined science, still you'll be able to really know what's really going on here. So you're asked to describe fully the motion of the car represented by these lines. Okay, so this one, it's a way of us recording the way that a car is traveling. Okay, so here your it's AB is done for you. Okay, this is acceleration for the first 20 seconds at 0.9 meters per square second. Okay, so this one is acceleration rate. So they're very specific about the way that they're writing there. So we'd say that this one you actually see that the speed is not changing. So if the speed is not changing, it means that this is a steady speed. Okay, so you can say constant speed motion. So accelerates, so you can say steady motion or constant speed. Okay, so maintains a steady speed. You actually have to say what's the speed. Okay, so here you won't be able to see really, but then I think these ones, there are like 10 of them. So let's see, 2, 4, 6, 8, 10. Yeah, there's like 10 of them. And then we have how many? We have four at the top. So we are dealing with a case where this one represents 6 boxes. Okay, so 6 boxes, where each box here, because they are actually 5 units from year to year. Okay, so if there are 5 units from year to year, that means that each box will be having 0.5. Okay, so we have 6 boxes, so 6 boxes represent 3. So this one would actually be 15 plus 3, which is 18. So a speed, you say a speed of 18 meters per second. Then you say for how long? So between 20 and 80 seconds. So obviously for 60 seconds. So you should be able to explain these graphs very well. If you see if it's a speed time graph and then the speed is not changing, that means that someone is in cruise speed. Okay, they're just moving at a steady speed. They are not accelerating, they're not speeding up, they're not slowing down, they're just moving at cruise speed. Okay, so just maintaining that. And then we see that this car actually does this for 60 seconds. Okay, so here the important thing was to say first, it's a steady speed motion, so you identify it. Then you say the velocity. Then you say the duration here. Okay, so here they identified its acceleration. Then they say the acceleration rate. Then they say the time here. Okay, so that's it. And let's see if we can do for CD. So CD, what's happening? So CD here, from here to here. Okay, so CD, it's obviously deceleration. Deceleration is a negative acceleration. We know that this is deceleration just because this person is going from a high speed to 0. Okay, so this is obviously deceleration. So you should say decelerates for. Then you should say now the time taken. Okay, for the deceleration. So here this one actually coincides with the 70. Okay, so 70, then 80. So this one must mean that each box is worth 2. Okay, so 72 to 80. So it means that each box is worth 2. So this would be 82. This one would be 84. Okay, so you'd be thinking deceleration from here, then to here. Obviously, this one would be 10. Okay, so this one would be 12, 14. So for 14 seconds. Then you actually have to ascertain the deceleration here. What is it exactly? So you have to enumerate the deceleration. If you want to find the deceleration, use any 2 points. So point C here, point C, we'd say that this one was 18. Okay, so point C is it's 70 seconds. Then here it's 18 meters per second. Okay, and then point D is this one where we said it's 84 seconds and 0. Okay, so the deceleration is equal to gradient. So for a speed time graph or velocity time graph, the deceleration is equal to the gradient. So the gradient of this, it's equal to change in y. So change in y here, so we can start with this. So change in y would be 18 meters per second minus 0. If you want, you can just say 18 without involving the meters per second. Okay, if you don't want to show how the units work out. So this one would be this one minus 84 seconds here. So it would be equal to 18 over, then this one would be equal to negative, is it negative 14? Yeah, so it's negative 14. Then here would be meters per second squared like this. Okay, so 18 divided by negative 14 would be equal to 9 over 7 meters per second squared. Okay, don't forget the negative. If you want, you can even change this to so you can even say negative 9 over 7 meters per square second. Here it's still fine, but then you can also change it to a decimal. So 9 over 7, you can say 7 into 9, it's equal to 1. Then you're left with 2. Then 7 into 20, it's equal to 7 into 20, it's equal to 2. Then you're left with 6. Then 70 into 7 into 60, then it's equal to up to 56. Okay, so it'd be 8. Then you're left with something. Okay, so you can actually approximate this to 1.3 approximately. Okay, so you can say deceleration, then you say the deceleration rate is 1.3. Okay, or 1.3 meters per second squared like this. Okay, which actually makes sense because this one is not broader than this one. This one, it's really steep. If you are asked to go either, let's say it's a mountain and then you have to go up here or up here would be difficult. Okay, so that means that you're dealing with a greater rate there. So the rate is actually 1.3 here. So this is how you explain the deceleration rate. Okay. So I'm going to rub off pretty much everything. Let's see what's really required. Okay, so we are required to find the total distance. So I have to rub pretty much everything except for okay, so let me just remove these ones. Okay, so we should be fine with this space right here. So we should be fine with the space right here. Okay, so that's it. And you're asked to find the total distance. The reason I didn't rub off everything is that we actually need this coordinates here. This coordinate, we know it's 0, 0. Okay, so but then this one we have to set in as well. So we know that this y it's not changing because it's a straight line. So we're dealing with the case where you have to set in the x one, it's 20. So this one is 20 seconds. This one it's 18 meters per second like this. Okay, so the reason I wanted these ones is the distance, total distance traveled. So you can say sigma again, then you say distance. They all understand. Okay, they know that it means total. It's equal to here you're dealing with a case of if you want to find the area. So for a speed time graph, the area under the curve, that's the actual distance. Okay, that's the total distance. So we just have to find the area of this shape here. Okay, so this shape, you first have to identify it. It's a trapezium where these are the two parallel lines. Okay, so the formula for a trapezium is equal to half, so it'd be half A plus B by H. Why? Because we're dealing with two triangles there. Okay, so two triangles or just a trapezium, so it's equal to half A and B. They're the parallel sides, so you're dealing with a case of from here to here. What is it? So here it's 84 seconds. Okay, so you can even write 84 seconds, or you can just write 84. It's still fine. Okay, so plus B, we're dealing with a case of from 22 to 70, so we're dealing with 50 seconds. Okay, so from 20 to 70, we're dealing with 50 seconds here. Multiply by the height. The height is obviously 18 meters per second here. Okay, so here you get half, then here you get this one would be 134 seconds. This one would be 18 meters per second, like this. Okay, so make sure that this one it's not seen as if it's a 5. So here you can actually cancel this one and get 9 here. Okay, so you get 9 times 134, so 134 by 9. So 9 times 4, you get 36. 0, okay, 3, then you get 9 times 3, then you get 27, then plus 3, then you get 30. It's 0, okay, 3 again, then 9 times 1, then you get 9, plus 3, then you get 12, like this. Okay, so it'd be 1206 meters. Okay, so this would be the actual distance, the total distance traveled by the car. So this was quite interesting, and I really liked it. So that's it for this video. Make sure you like, share, and subscribe. Catch you in the next video. Yubo out.